function is something for drawing pictures. Now, when you first start out trying to draw a function, the easiest thing is to create a table labeled like so that helps you generate the coordinates that you need to plot. In the first column, put the word input, and then immediately next to it, function, which I'm going to abbreviate, then output, and then coordinates. The input will always be the thing that you start out with and basically what you plug into the function. And those will mostly, they can be the other way, but they'll mostly be x values. So if you want to just, label it yourself so it's clear, write x's. Right? The output is what you will generate, and that will be y's. Together, they'll be your coordinate x comma y. And you'll have several. The function could be literally anything you can imagine, which is why I argue that it's actually an enjoyable pastime. Let's just say we make it look like this. Y equals something that follows it. So if you want to make it relatively interesting, why not do something that has an exponent? So x squared minus 1, say. That'll be a function for this particular graph. All right, now just to help clear up a little bit, I'm going to draw imaginary column lines here to separate. All right, and we're going to fill in this. When you first attempt to generate coordinates, always start with something small. As a matter of fact, the 5 x's you could use virtually forever, all right, for any function. It doesn't necessarily have to be this one, it could be anything. The reason that you would choose this, -2, -1, 0, 1, and 2, is that it gives you equal amount of negative values as well as positive values, and the numbers are relatively small, so they're easy to work with. It's like, for example, when you have 0, 0 times anything is going to be 0. All right? And if you have something that's times 1 at least, it's going to be just what it is. And times 2 is not difficult to deal with either. Anyway, so in your table that you're constructing, all right, put -2, -1, 0, 1, and 2. Then basically what you do is that you start doing substitution. Right? If you're not familiar with that term, substitution basically means that wherever there's an x, you're going to put these numbers. Having done this calculation with these values will give you a y value in return, which is why mostly, at least in the very beginning, functions are already written for you as y equals some expression on the other side. Now, being that, even though this is an equation, because you're not moving anything over the equal sign, you're just sticking with traditional order of operations. All right, there's no opposite operations, it's just straight arithmetic, and you start with the most important thing. In this case, it's exponents. For the first one, if you have y is equal to -2 in place of x minus 1, what would be more important, doing the exponent or the subtraction? You always do the exponents first according to, please excuse my dear Aunt Sally. What comes from that? If you have something that's raised to the power of 2, you probably know that that's an instruction that you write this number twice and then do multiplication. But of course it's going to be -2 times itself, so that's -2 times -2. I always draw a little line and put the answer just above the other thing I have to do next. -2 times itself is +4. Now if you do 4 minus 1, what are you left with? +3. So the combination of these, therefore, the first coordinate will be -2, +3. You don't have to put the +3, but I like to. In your next space, you substitute -1. So in place of x, we stick -1 squared minus 1. And then follow the arithmetic as you would the order of operations again. So, -1 squared is -1 times itself. 2 negatives make a positive when you multiply, and therefore you have +1. 1 minus 1 is left over, and that is just plainly 0, which is neither positive nor negative. Even still, your coordinates, therefore, are this: what you started with and what you ended with. If you've never done graphing before, here's basically how it works. Remember that the horizontal line represents x values. If you head in this direction, if you go past this point where the two main lines intersect, the origin, these are all negative x values. So if it helps, you could label this negative x. Similarly, if you go down, these would be negative y values. When you're graphing these, it's not bad. Just don't make the mistake most people do the first time they do it. That is, namely, they end up making two dots when they should just make one. Do not make a dot on the coordinate plane until after you have moved the second number amount. So the first one is -2, +3. You always start at the origin. If it's -2, and remember this is an x value, how many spaces would you go to the left? 2 spaces. So you count 1, 2. Leave your pencil point or your pen there at that point. Just don't make a mark, and not a serious dedicated mark. +3 represents going up from that point. 1, 2, 3. Then make a dot last. Alright, this is the coordinate -2, 3. The second coordinate should be -1, 0. Alright, again, you start at the origin. Don't attempt to make a point from here where you left off. Go back to where you started, origin. -1 is over to the left 1, and then 0. If it's 0, can you go up or down? No, you simply stay put in that instance, and you make a point there. 0, -1. If you start out at 0, you could go neither left nor right, so you stay put for the x portion of it. -1 says that you go downward, so you put down 1 here, a point. +1, starting from the origin, over to the right 1, and then up no amount. And then lastly, back at the origin, +2 is 1, 2, over to the right 2, and then +3 is up 3, 1, 2, 3. You will notice that you have something, provided you do the calculation correctly, that's symmetrical. This happens to be a particular type of function. Normally people don't start out with this function. This is usually the second type. It's called a parabola. A parabola is, it looks sort of like a V, but it's not quite. If you had done numbers that are in between the whole numbers, like say -1.5 or -1.25, you'd start and it would be difficult to graph because the graph lines are not that size, they're not incremented that way. You would start to see that you would fill in points in between the whole number points. Anyway, and they form a shape that basically looks like this. The reason it's not a V shape is because it doesn't make a straight line from here to here. If you did that, you'd be bypassing this point here. Instead, it forms a curve, right? And if you did points beyond -2 or +2, they'd go into infinity upward. Right? It's not a U shape either, because a U shape would not have literally a sharp point like this. It would be more curved, right? So it's neither U nor V, right? It's instead this thing, a parabola, right? What you should always do when you do any sort of graph, right, as long as it's continuous, which means that these points would be filled in between the whole numbers that you tried, you should extend the lines by guesstimating, all right, into infinity. You represent infinity by these arrows at the end lines, right? And this should be your end result, a parabola. A less complicated problem would be something that's not x power of 2. All right? Usually that's the one, again, that they start out with. They don't usually start out with parabolas. I just happen to find them more interesting to do. All right? Later on, you get into x powers of 3. And you get sort of a funny, almost, I don't want to say S shape, but it's curved. It looks like a parabola that one chunk of it has been inverted this way. All right. But generally, x powers of 1 are actually straight lines. All right. This is still a function because you notice that the x values are not repeated. Right? Just because something has the same digit does not make it the same number. It has to have also the same sign. And this is +2 and that's -2. So it obeys the formal definition of a function as well. This parabola that is in that direction is a function.